Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will explore how to solve a linear and quadratic system of equations. Now, a linear quadratic system is a system that contains one line and one parabola. When dealing with a straight line and a parabola, there are three possible ways they may appear on the graph, giving three possible solution situations. So, if your line intersects your parabola in 2 points like this, it intersects here at the top and here at the bottom, this means you're going to have two solutions. Two solutions. If your line only intersects your parabola one time, this means you'll have one solution. If your line and your parabola never ever intersect, that means there are zero solutions or no solution. To solve a linear quadratic system means to find the point or points where the line and the parabola intersect. This can be done graphically or algebraically. In example 1, it says use substitution to determine whether the ordered pairs 0, 5 and 418 are solutions to the system shown below. So, our solution is a quadratic equation, y equals 3x squared minus 8x plus 5, and a linear equation, negative 4x plus y equals 5. For these ordered pairs to be solutions, they must make both equations true. If they make one of the equations false, then that ordered pair cannot be a solution. So let's check the ordered pair 0, 5 first. In that ordered pair, 0 is our x value and 5 is our y value. And we're going to take our first equation, which is our quadratic equation, y equals 3x squared minus 8x plus 5. And we're going to substitute in these values for x and y. So I'll substitute in a 5 for the y and a 0 for the x. And then I want to evaluate both sides. So on the left side, we're just going to have 5. On the right side, we have 3 times 0 squared, that would be 0, minus 8 times 0, that's also 0, and 0 plus 5 is 5. So it definitely makes the first equation true. Now, just because it makes the first equation true doesn't mean it's a solution. We have to also try it in the second equation, which is negative 4x plus y equals 5. So I will plug in a 0 for the x and a 5 for the y, and then evaluate both sides. So negative 4 times 0 is 0. 0 plus 5 is 5. So that side becomes 5, and this side. So now we know 0, 5 is a solution. 0, 5 is a solution because it made both equations true. All right, now we're going to check the second ordered pair, 4, 18. 4, 18. Now in this ordered pair, our x value is 4 and our y value is 18. So let's take our first equation, y equals 3x squared minus 8x plus 5. And I'm going to plug an 18 for the y and a 4 for all the x's. All right, so this side is 18. Now I'm going to use my calculator to quickly evaluate the other side. 3 parentheses 4 squared minus 8 parentheses 4 plus 5. So the other side is 21. So this would be not a solution. So 418 is not a solution. Not a solution. All right, example 2. Hold on, let me box that in. The parabola given by y equals 3x squared minus 6x plus 1 and the line given by y equals x minus 1 are shown below. Now, this linear quadratic system has two solutions. the first one being here, the second one being here. Now, one of the intersection points is clearly identifiable from the graph. Pause the video and see if you can figure out one solution to this system. All right, welcome back. Hopefully you said that the ordered pair 2, 1 is a solution to the system. Okay, now we're going to find the other point algebraically. So let's look at this other point. I want you to notice that it goes to the right and then down, which means our first number of our ordered pair is going to be positive, and the second number of our ordered pair is going to be negative. All right, to solve this algebraically, what you want to do is take the equations and make them equal to each other. So we have 3x squared minus 6x plus 1, and I want to make that equal to x minus 1. All right, now I'm going to get all the terms on the same side. So I'll subtract x from both sides, and I'll add 1 to both sides. All right, so that would give me 3x squared minus 7x plus 2 is equal to 0. Now, you could solve it from here. You could solve it by completing the square, quadratic formula, or factoring. But when the numbers are this small, I tend to just solve these by factoring. Now, I'm not going to do a reteach on factoring. I'm just going to assume that you know how to factoring. If you need to pause the video and kind of work on your factoring skills, feel free to do so. But 3x squared, I will factor as 3x times 1x. And for the 2, I'm going to use 1 times 2. I'm going to make those both negative. Now, I really only need to solve this factor because I already know that x minus 2 will give me an x value of 2. So what I'm going to do is if 3x minus 1 is equal to 0, then I would add 1 and divide by 3. So now I know my other intersection point is 1/3 comma something. And that makes sense that it's going to be a fraction. If you look at the graph, you can see it's going over just a little bit. It's only going over a little bit. So in this case, we know it's going over 1/3 of a unit. Okay. Now, to get your y value, you're going to plug it in the more simple equation. So I am going to use this y equals x minus 1 to plug it in. So to get my y value, y equals, instead of x, I'll put in a 1/3 minus 1. So 1/3 minus 1 is negative 2/3, and that will give you your y value. So now we know both solutions to this system of equations. All right, so what do you do if they don't give you a graph and you can't really figure out what the solutions are? In that case, you're going to solve the system algebraically. And the way we do that is we make the two equations equal to each other. So in problem A, we have y equals negative x squared minus x plus 6, and y equals x plus 3. So I want to take my first equation, negative x squared minus x plus 6, and I want to make it equal to x plus 3. Now to solve this, let's get all the terms on the same side. All right, so this would give me negative x squared minus 2x plus 3 equals 0. Now, I don't like to solve things by factoring when the first term's negative, so I'm going to multiply everything in this parenthesis by negative 1, and that would give me positive x squared positive 2x minus 3 equals 0. Now I'm going to factor that. So for x squared, I'll use x and x. For 3, I'll use 1 times 3. Make that positive and that negative. So this tells me I'm going to have a solution of x equals 1 and x equals negative 3. So I'm going to come down here and write my ordered pairs. All I know about my ordered pairs right now are the x values. I only know my x values. To get the y values, you're going to plug these values into the more simple equation. So I'm going to plug these into this equation here because it's more simple to work with. So we have y equals x plus 3. To get the y value, I will plug in the x value, which is 1 plus 3. And 1 plus 3 is 4. So I know my y value is 4. Now I'll do the same thing over here. Y equals x plus 3. And I will plug in a negative 3 plus 3. And that works out to be 0. Now, what I like to do is check these on my graphing calculator. I'm going to use Desmos, but you could use any graphing calculator. I'm going to type in our original system, negative x squared minus x plus 6, and then x plus 3, and then press negative 3, 0, yes, and 1 comma 4. So that tells me we did our algebra correct, and I've got my solutions. All right, look at problem B. Y equals 2x squared plus 12x minus 7, and negative 3x plus y equals negative 2. Now, this problem is a little different from A, because if you look at your second equation, we do not have the y by itself. So before you do anything else, go ahead and get the y value by itself. So add 3x to both sides. So that would give me positive 3x minus 2. Once you do that, now you can put the two equations equal to each other. So 2x squared plus 12x minus 7 is equal to 3x minus 2. Now get all the terms on the same side. So I'll subtract 3x and add 2. Now let's see what that gives me. 2x squared, 12 minus 3, that would be 9x. Negative 7 plus 2 would be what? Negative 5. And this side would equal 0. Now I'll go to the factoring part. Again, I'm going to assume you already know how to factor, so I'm not really explaining my factoring. But I'm going to use 2x and x. For the 5, I'm going to use 1 and 5. Making that positive and that negative. Yep. Okay, so that would give me my first x value, if I solved it, would be positive 1/2. My second x value would be negative 5. Now, I'm going to come down here, and I'm going to put my ordered pairs. We're going to have 1/2 comma something and negative 5 comma something. All right, to get the comma something, I'm going to go with this more simple equation, y equals 3x minus 2, to plug into. So y equals 3 times 1/2 minus 2. Okay, so 3 times 0.5 minus 2, and that would give me negative 1/2. So now I know my my y value of my first ordered pair. All right, now I'm going to come over here and take y equals 3 times negative 5 minus 2, and that would give me negative 17. Okay, then I want to check my algebra. So to do that, I'm going to graph our original equations, 2x squared plus 12x minus 7, and then 3x minus 2. All right, I need to zoom out a little bit so that I can see both. So negative 5, negative 17 checks out, and then check this other solution right there. 0.5 comma negative 0.5, that's exactly what I have, although I've written in fraction form, same answer. All right, so we checked our solution by graphing on a calculator. All right, problem C. We have y equals 2x squared minus x plus 1, and y minus 4x is equal to 4. So if you'll notice again, on the second equation, I need to get the y by itself. So 4x plus 4. Now let's take that first equation, 2x squared minus x plus 1, and make it equal to the second equation, 4x plus 4. So subtract the 4x and subtract the 4. All right, so 2x squared minus 5x, 1 minus 4 is negative 3. Over here we have 0 left. All right, I'll solve this by factoring 2x times 1x, 1 and 3, negative, positive. So x is going to equal negative 1/2. X is going to equal positive 3. So I'm going to write down the first part of my ordered pairs. Now, as far as which equation to help you get the y value, I would use my most simplified equation, which is y equals 4x plus 4. So y equals 4. Instead of x, I'll put in negative 1/2 plus 4. So negative 1/2 times 4 is negative 2. Negative 2 plus 4 is 2. And then y equals 4 times 3 plus 4. 4 times 3 is 12. 12 plus 4 is 16. So again, we'll come over here and check it on the calculator. 2x squared minus x plus 1. And then 4x plus 4. I'll have to zoom out a little bit to see where they intersect. So there's the first one. Negative 1/2, positive 2. We got that one right. So I'm going to come up here and find this one. 3/16. That is also correct. So I could go ahead and box in my answer. Now, pause the video and try problem D on your own. All right, welcome back. I hope firstly that you solved this top equation for y and got positive 3x minus 16. And then I hope that you made these two equations equal to each other. And then I hope that you got all the terms on the same side. So let's see, that would give me x squared minus 4x plus 4 equals 0. So that would give me, if I solve this by factoring, x and x, 2 and 2, they'd both be negative. So, this is an interesting case, because in this problem we're only getting one x value. That means in this parabola and line, they're only going to intersect in one place. So I got the x equals 2. Now, I'm going to plug that 2 into this equation to get my y value. So y equals 3 times 2 minus 16. So 3 times 2 is 6. 6 minus 16 is negative 10. Now all we have to do is check it just to make sure we didn't make an algebra mistake here. 3x minus 16 and x squared minus x minus 12. I need to zoom out a little bit. See, it intersects somewhere in here. Positive 2, negative 10. That's exactly what we got. So we can see clearly the way this this parabola intersects this line. It's only intersecting in one place. So we had one solution. And that concludes today's lesson, solving linear and quadratic systems.